Thank you, Fernando. Thank you, everyone. My name is Paolo Corti, and I am researcher for the Innovative Building Scheme team at SUPSI. Today, we are going to speak about the BIPV status report 2020 that has been developed by SUPSI and the Becquerel Institute within the framework of the European project BIPV Boost and the Swiss Federal Office of Energy. This publication was also possible thanks to the collaboration with our partners, Solaccess, Solis, Solin, and Sanovations, all companies operating within the BIPV and the photovoltaic sector. If you didn't make before, please, if you want, download the BIPV status report, simply this for free, simply scanning this QR code, or visiting our website, solararchitecture.ch. You can find here some information about BIPV, new publication, events, case studies, and more information. So basically, the BIPV status report 2020 is the third edition of the status reports that SUPSI present more or less every 2-3 years, every time together with the different partners. This year, we had a great collaboration, as I mentioned before, with the Becquerel Institute. This picture is a word cloud that is the visual representation of all the words used within the BIPV status report, on which the importance of each word is shown with the font size. And for us, this picture is quite important because it is able to show that BIPV is a part of a huge and complex process, where different topics are involved and also different stakeholders should be involved. Indeed, the BIPV status report 2020 was made also including involving the industry, the research field, the architects, the planners, for example. And at the same time, the target of the BIPV status report are all the stakeholders of the BIPV and also the building value chain. This picture for us then is also quite interesting because it shows the idea that is behind the BIPV status report. That first is to face different topics of this complex process, from energy evaluations, market analysis, economic evaluations, normative framework, for example, but also we tried to make an analysis of this topic at different level of complexity. Indeed, we provide, for example, a detailed methodology to evaluate the cost competitiveness of photovoltaic system, and at the same time, we also analyze real BIPV case studies from an energetic, economic, architectonic, and technological perspective. In order to involve also the new or potential stakeholders of the BIPV chain. As a conclusion, the BIPV status report, we call the BIPV status report a practical handbook for solar building stakeholders. The webinar of today basically is organized following the structure of the BIPV status report. I will start now with a short introduction of the BIPV evolutions. After my presentation, Philippe Macé and Elina Bosch from the Becquerel Institute will present the BIPV market and BIPV value chain, and also an economic evaluation of BIPV, presenting a methodology to evaluate the cost competitiveness of BIPV and the real cost of the investment. In conclusion, Pierluigi Bonomo from SUPSI will present the new trends and the perspective for the BIPV. In general, the idea of this webinar is to provide only some pills, some highlights of the BIPV status report in order to arouse of course, the BIPV status report and in general, the BIPV's curiosity. Okay, so the acronym BIPV became in the last few years, more popular. But the history of integration of photovoltaic system in buildings started almost 40 years ago. You can see the top left black and white picture. It represents the first European BIPV installations, that is the Wohnanlage Richter, realized by Herzog in 1982. But even before, 20 years before, in the 60s, the Italian architect and thinker Sergio Loss, within the framework of his studies related to bioclimatic architecture, said that the architecture should be adapted to the geography. So the architecture should be contextualized. And in particular, he said also that the house becomes a solar collector. And I believe that this idea, this concept is quite interesting because today we are developing new tools, new products, BIPV products, new procedures, also the social interest for nearly zero energy buildings, for integration of photovoltaic systems in buildings. And finally, we can say that now we have and we are able also to create and to transform buildings in solar power plants. Within this picture, you can see the Wohnhaus Solaris, that is a multifamily house realized some years ago, few years ago in Zurich. And you can see that the photovoltaic system is customized and red colored, is integrated in the facade and in the roof. After several BIPV case studies analyzed, I feel quite comfortable to say that the best practice, the best BIPV practice, and are those buildings that are able to find the balance between the technology, so the photovoltaic system itself, and the traditional component. Or we can summarize this idea saying that today we are able and we should consider, we should treat photovoltaic systems, BIPV, as building material. Of course, considering their features, their characteristics, and of course, contextualize each project. You can see here in this picture, the rural house, Galley, realized also some years ago. And to me, this is a quite interesting example of photovoltaic integration. The photovoltaic is installed on the roof, on the biggest part of the roof, and it is customized and colored. It's interesting also that these buildings is a protected and historical building. As we made within the previous version of the BIPV status report, also this year we provide a database of a European BIPV product and mounting system. And at the same time, we also provide a detailed explanation of the description of the technological system of the building. So in conclusion, I would like to say that today BIPV is a reality within the building sector. So we cannot hide this, and we have to accept this. And the stakeholders of the building value chain cannot avoid today to consider BIPV. Of course, there are still some barriers to be overcome and to enlarge the market. We saw that the process, the BIPV process, is not quite easy, but today the challenge is to support the BIPV market growth. by realizing or demonstrating new buildings and demonstrating BIPV in more buildings, and also by introducing innovative and multifunctional products and processes. With this, I finish my introduction. Thank you very much, and please, Philippe, the stage is yours.
Thank you, Paolo. Okay, let me share my screen. Okay, so hello everyone. Thanks for being here. So on my side, I will talk about the market and value chain of BIPV. More specifically, I will try to give an overview of the risks and opportunities there is on this market. So an important first step when we start talking about the BIPV market is to understand that it is an extremely diversified market. Okay, it's not like we can have fully standardized and commoditized products. This is really differentiating from one project to another, and we can have BIPV solutions for roofs, for facades, or even as external devices like balustrades, for example. So there is a high range of BIPV application possible, but also even for each of these applications, well, multiple BIPV products exist on the market, and they have different specifications in terms of performances or colors, like you could see on the BIPV product database that Paolo mentioned. And it's also important to understand that in function of the market segment we are focusing on, well, these trends are very, very different. For example, on the residential segment, it's mostly residential roofing BIPV solutions that are pulling the market, while in the case of commercial buildings, it's more facade installations. So that being said, we can also have a look at the history of the BIPV market before talking about its current status. So as you can see here on the right, the European BIPV market had a tremendous growth at the years 2010, early 2010s, especially between 2008 and 2011, when it peaked at more than 2 gigawatts installed in Europe. This was mainly due to markets in France and Italy, which were actually created by very, very generous financial support schemes, which were first introduced in 2006 and 2007. And actually, we see also that as soon as these very generous support schemes were adapted or even disappeared, well, the market kind of collapsed, and it progressively decreased to reach in the last years volumes between 150 and 200 megawatt peak per year. Another point which is very important when we look at these historical numbers is to keep in mind then what was defined as BIPV at that time, like in 2010 or 2011, is very different from what we understand and we agree to define as BIPV today. So the rules were much less restrictive at that time, which can explain also why the BIPV volumes were so massive. Then looking at today's situation and especially how it could evolve in the short term, we see that the perspectives are quite favorable. So on the European market, our analysis shows that this year in 2021, the market should be higher than 300 megawatt peak overall, and that it could actually reach 500 megawatt peak next year and even break the 800 megawatt peak in a very favorable scenario in 2023. So this is a very growing market, and this is mainly due to key countries like France, Netherlands, Switzerland, or the United Kingdom. One important thing to note also is that this growth is mainly due to the residential segment, especially so roofing BIPV solutions for the residential segment with, for example, PV tiles or what we call in-roof mounting systems using conventional PV modules or adapted PV modules. So the perspectives are quite favorable. And it translates also into a significant business opportunity. Here we have the same numbers basically, but translated into monetary value. And we see that in the very short term, so by 2022, the €1 billion business opportunity for the entire European BIPV market could be passed, and this could reach more than €1.5 billion the following year in 2023. And this growth in value and in the market size, well, is mainly due to cost reductions. So many technical innovations are entering the market steadily, leading to cost reductions and reducing the gap with conventional construction materials. We see also higher possibilities to customize the BIPV modules, and also on the regulatory side, of course, there is a high increasing pressure to improve the sustainability of buildings. Should it be new buildings, but also older buildings through renovation. An important thing to understand also when analyzing the market and the value chain is the power and the influence, I would say, of the stakeholders which are involved. Here we have a chart where we have positioned some key stakeholders of the BIPV development process in function of their interests in the adoption of BIPV in a project and their influence on this possible adoption of BIPV in a project. And we can see that actually there is no market pull, as we call it, in the sense that the usual actors of the construction sector, like the general contractors or the architects, well, they have only low interest in seeing the adoption of BIPV in a project, although they have a very high influence. And why is that? Well, it's because maybe they can feel that it had some complexity and problems to their project, and in any case, they don't have any we'll say, well, no direct added value for BIPV on their side. We can also see that policymakers have a tremendous influence and only a medium interest. And another point to really highlight is also that we see different positions for the building owners on one side and the building occupants on the other side, with well, different influence and also different interests, which can also explain why in some cases there are high barriers to the adoption of BIPV, because their interests are not aligned. So this is also something for which innovation is necessary. So if we would try to summarize what are the real key remaining challenges or weaknesses of BIPV and what could hinder its development, we can identify 4 main axes. So first, there is the fact that the value proposition of BIPV can sometimes seem blurry, because there is still a cost gap with conventional PV and construction materials. So this will be discussed by my colleague Elina in the next slides. But there are ways to tackle this issue. For example, we will present also in the next slide a methodology to conduct a very detailed project cost competitiveness assessment. And this can show, even though there is a cost gap at material or component side, that there is an interest, a real economic interest in BIPV. Also, we see that there is still a lack of knowledge and some resistance to change within the building sector. This is not totally, I would say, a problem. I mean, this is a natural issue in the sense that, as we showed previously, the interest of some usual actors is not very high. We can try to promote this attraction of BIPV by education and, for example, through guidelines, but also by providing digital tools which could ease the work. Then also we can mention the fact that there are other investment strategies which can be more cost efficient in some cases in order to reach nearly zero energy building requirements in Europe. So again, this can be tackled by doing a detailed project cost competitive assessment, but also on the side of the regulatory makers, this could be overcome by strengthening actually the NZEB regulation and pushing more towards positive energy buildings rather than nearly zero energy buildings. And finally, on the normative side, we can also mention the fact that there is still a lack of standardized product qualification procedures for BIPV, in the sense that they have to do on one side the electrical standard compliance, and on the other side the building related compliance testing. There is no procedure which combines both aspects, which is still a problem in terms of cost, for example, for the BIPV manufacturers. And in the end, to give some path of evolution and some keys to boost the BIPV market, we can mention some key aspects. For example, it's really crucial that all stakeholders have in mind that it's crucial to design technical systems that favor an easy repairability and replaceability of components, because it can reduce cost, but also risk perception, for example, from the side of usual actors of the construction sectors. It's also, in order to reduce cost, crucial to try to think modular and prefabricated when designing a project or a BIPV component. And then, as I said, still the issue of standards combining both electrical and construction features or digitization of procedures, which are really key aspects and should really be, should really contribute to boosting the BIPV market. So I will now leave the floor to my colleague Elina, who will talk to you about cost-related aspects.
Thank you, Philippe. I will share my presentation, which will focus on cost evaluation of BIPV. So, since it was already mentioned before, BIPV combines different functionalities. So it's a building construction element. It also generates electricity, and it can also generate savings and extra revenues. This is why the cost competitiveness of BIPV can be approached in different ways. So it can be compared to the cost of conventional construction components. It can be also compared on a system level with other construction systems. It can also be assessed as an electricity generating unit. So by calculating its LCOE and putting it into perspective with other generating units or with retail electricity prices. And finally, it can also be evaluated as an investment by taking a more holistic approach, considering both its costs and revenues. So when comparing BIPV as a construction component, the comparison can be made for roof and facade products. So on average, roof BIPV components are more expensive than conventional roof construction elements, but the cheapest BIPV product, which is based on conventional PV modules, can be cheaper than some conventional high-end products, such, for example, as slate tiles in the case of residential roofs, or metal sheets in the case of industrial roofs. For facade, the general conclusion can be drawn, except that in the case of facade, there are conventional products that can come at really high cost, for example, stone. So BIPV glass construction components are more expensive than most conventional facade components, but they can challenge some of the most expensive conventional elements. moving the comparison to the system level, most conventional roofing solution can be challenged by BIPV solution, in particular when we are looking at in-roof mounted conventional PV systems. They are particularly competitive. And on the other hand, we have more expensive BIPV solution, tailor-made BIPV solutions, but which can offer other advantages in terms of aesthetics, but also in terms of other building-related functionalities. And when facades are compared on the system level, again, same general conclusions can be made, which is that BIPV facade systems can be competitive when they are compared with some high-end conventional systems, for example, insulated glass. So when looking at those numbers, it should be beared in mind that BIPV is not only a construction element, it also generates electricity, and it is comprehensible that this additional functionality also leads to higher costs. This is why evaluating the competitiveness of BIPV with a holistic approach gives a better idea of the actual competitiveness of BIPV. So in that sense, to evaluate the total costs and revenues of ownership of a BIPV project, the idea is to gather on one hand the cost of BIPV, and in particular the extra cost of BIPV compared to a conventional system, and on the other side to evaluate all the revenues which are possible thanks to BIPV, mainly savings on the electricity bill or valuation of excess electricity or any other incentives. With these costs and revenues, cash flows, the net present value can be calculated over the system's lifetime of 30 years. And by dividing this metric, this result by the system, BIPV system surface, we obtain a metric in euros per square meters corresponding to the competitiveness. And this result is really easily interpretable, since when it's positive, it indicates that the extra revenues of BIPV outweigh the extra cost, and so that is worth it to invest in this extra investment to invest into BIPV. So going back to the extra cost notion, so this approach really allows to take into account the multifunctionality of BIPV, and it allows to rapidly and easily compare BIPV to a conventional construction system. So in order to determine this extra cost, the total end user cost of BIPV needs to be broken down into each of its individual parts. And then for each of the cost items, it is determined which part is attributable to BIPV and which part is not. So typically electrical planning, electrical installation, cabling costs are 100% attributable to BIPV, and therefore they are gathered in the end in the extra cost. The module cost, for example, is partially attributable to BIPV. This is because if you consider a conventional system, you'd have to pay for the conventional system's material, for example, ceramic tiles. So this offset construction material stays in the fixed cost, and only the remaining part of the module cost goes into the extra cost. So in the end, when we gather all costs and revenues associated to BIPV, the competitiveness can be evaluated. Here we have the result for one typical roof solution and in a residential roof, and then one example of a typical commercial facade. So here the typical roof solution consists in approximately 6 to 8 kilowatt peak installed, covering a surface of 50 square meters. And in this residential case, there is assumed that around 30% of the production is self-consumed on an annual basis. So globally, for the 4 studied countries, so France, Netherlands, Italy, and Switzerland, roofing BIPV solution in the residential segment are globally already competitive. So the generated electricity and the revenues it allows largely covers the extra cost due to BIPV. And overall, it allows to a revenue of around a couple hundreds of euros per square meters over the 30 years considered, the 30 years of system lifetime. And in particular, when we are considering an in-roof mounted conventional BIPV system, which is a less expensive BIPV systems, the competitiveness level reached for the different countries are particularly attractive. Moving to a commercial facade solution. So in this case, we'd have a capacity installed of around 35 to 40 kilowatt peaks, covering a surface of 217 square meters, and a considered self-consumption rate of 90%. So in this case, overall competitiveness is not as straightforward as for roof. This is due to several factors. The first one being that BIPV installation on facades are exposed to non-optimal irradiation conditions. The second one is that facade systems are on average more expensive than roof systems. And finally, since we are considering a commercial case, the electricity price is lower, therefore savings on the electricity bill potential is also reduced. So globally in the Netherlands, in France, so for France, we have been considering a central location in France. Overall, lower compensable retail price apply compared to European average, and also less optimal irradiation conditions than in southern countries, resulting in competitiveness threshold not being reached, but almost. In Italy, on the other hand, we have rather higher retail electricity prices and higher irradiation conditions, and this allows to reach a competitiveness that is positive. And finally, in Switzerland, we have an exception in the sense that there are BIPV specific directive incentives and also relatively generous feed-in premiums. And here, once again, competitiveness threshold is reached and exceeded for both considered ventilated BIPV facade. So this gives an overview of the current competitiveness of BIPV, and Pierluigi will provide an overview of perspective for BIPV. Thank you.
Thanks, Elina. Hello, everyone. Thanks also for the slide. Hello, everyone. Welcome also from my side to this webinar. My name is Pierluigi Bonomo. I am a researcher at SUPSI, and I'm also head of innovative BIPV building scheme. So first of all, I mean, very brief thank you to Copper Alliance and to my colleagues for previous presentations, and of course to the supporting partners and projects which supported us for this report and for this event. Above all, of course, thank you everyone for joining this webinar. And my idea, honestly, as you see, I opened with this question, but my idea is not really to reply to this question, because I think my colleagues already did in brief, And I also hope that you will find some concrete indications within the report, which we really conceived as a practical handbook. What I will try to do is rather to put on the table some points and some reflections that we did across this experience, and thanks to also to the supporting projects, experiencing, I mean, the real value chain, by talking and discussing with real players, with industries, and with real stakeholders. So at the end, what is behind this question is another question. So it's maybe to say if we really want to support the market growth of BIPV. So if we want to go beyond this 1 or 2%, which is the current market, and or on the other hand, if we still consider BIPV as a luxury or a special element and technology for special buildings. I think this is the point of discussion today, and I hope that every one of us, and I'm pretty sure, is here trying to shape the first strategy. So really for making a stronger and larger the BIPV market. Next slide, please, Elina. So if we want to really see this market grow, what we realized is that maybe the answer or the perspective is not just one, but I'm pretty sure that the key point of BIPV is to really include and integrate many perspectives on the same topic. I listed some aspect here that we see as key drivers of today's innovation in this sector, and it's really evident how this field ranges across product and process innovation, and it really involves on one hand architecture, design, and style, and on the other hand technology, industry, and every of these factors should be really integrated then thanks to a digital process and more and more cost competitive solutions. But in the real field, we still see today maybe some different approaches. This picture, for example, I used many times. This picture I displayed in many conferences around the world, and still today I get very often two completely different reactions. So from architects, typically I have a reaction like, yes, this is a great way to integrate PV. These solar cells are really like natural leaves, and these colors are very nicely integrated in this building. But on the other hand, electric specialists and PV specialists react in a completely different way, because that's clear that shadings are permanently affecting this installation. So what's the energy yield? What's the efficiency of such an application, and so on. And I think this is still the debate today and the key point to solve. Next slide, please. We really could discuss on each of these points for a long time, but we can just take a look on what happened on the product technology in last years and in last decades. And I think it's quite evident that on the product and technology framework that we have today, the real key points of innovation on the successful technologies was an integrated effort of bridging together design principles with manufacturing and industrial needs, to bridge together building and electric innovation in a joint and in a unitary way, and so to really put together the key principles of innovation of these two different worlds. And today I think it's clear to everyone that we have market-ready technologies and products we have very successful products available on the market. And it's also clear that we shifted from a standard PV component to a real multifunctional building skin system, which of course includes much more than a regular PV element. Next slide, please. Also research, I would say, changed in last years, and we are experiencing more and more an applied research which is trying to support real applied results. It's more and more demo-oriented, so technologies is implemented, is demonstrated, and is validated. So also in this sense, we see that the effort is focused on a product level to develop a multifunctional and cost-competitive solution, but it's also aimed to support the real market implementation. And I just touch briefly a point which is related to the quality of BIPV systems. So to the real need to streamline the qualification, the testing process, and the market introduction of these technologies. And on the other hand, also the process is a key part of this market transfer, because thanks to the digitalization and the BIM-based approach, we see a very important potential of market implementation of the technology. So this is what is ongoing, for example, on this BIPV Boost project. So I invite you, if you already don't know this innovation action, to visit the bipvboost.eu website and to find also public report and much more information on what's ongoing on research. Next, please. I just reported here some aspect of the current framework, because I think every one of us is aware that we are in a historic moment, and just taking a look to what Europe is setting up, I think we realize that we have a very ambitious policy initiative on the ground, which plan to really review each existing action and regulation to go really strong towards circular economy, innovation, and really to reach a climate neutral Europe by 2050. And I think this is a very key moment to also push BIPV as a unique and promising approach for really producing energy in a decentralized and way. Renovation wave is one of the most important challenges in this direction. We all know that existing building stock is the real challenge for the future. And we see also here, we experienced across many product technology and also preparing this report that the potential is really, really huge for refurbishment of existing building stock. Next, please. I report in one of these initiatives, which is the new Europeanbauhaus, because I think that in BIPV we are already experiencing this cultural project for Europe since many years. As I said before, it's nothing new in BIPV, an interdisciplinary initiative. And this co-creation platform between architects, designers, and on the other hand, engineers and industries is ongoing, and is the key driver of innovation of our sector. So I'm really convinced that we have a very optimistic and promising framework for promoting and for implementing BIPV in these new initiatives in Europe and also beyond Europe. So just to the next slide to conclude, I wanted just to put on the table some key points that we experienced in this joint work, and also some outlooks on the very promising possibility that I think each of us has along the value chain to really drive the change. And I concluded again with the same question. So which perspective by also concluding with this graphical image of a vision for a future building 2050. This is what Arup Foresight imagined for a future building, and we see that of course photovoltaic is an essential part of this vision, but is one part of this complex building and urban system. And I think that this image also translates very well what Paolo initially displayed with that with the words cloud. So it's just a graphical translation of this approach. And I really conclude my presentation by reading this sentence of one of the key personality of the Bauhaus, which once said that architecture depends on its time. Technology and architecture are so closely related, and our real hope is that someday the one will be the expression of the other. So I just leave with this message, and I invite everyone to take a look to the report for really finding practical and concrete indications.